Welcome to BVS Pragati channel. In this session, let's discuss about some more aspects of transmission line. So in the previous session, we have seen that the reflection coefficient K varies from +1 to -1. So what is a radio frequency line? In a radio frequency line, alpha is 0. Z0 is equal to root of L by C. And since what is the propagation constant? It is equals to alpha plus j beta. Alpha is 0. So j beta is equal to root of j square omega square LC. So you get j omega root LC. So beta is equal to omega root LC. So a RF line is a distortionless lossless line. Zn is equal to Z0 into Zr plus Z0 tan j beta L by Z0 plus Zr tan j beta L. So if Z0 equals to Zr, we have seen Zin equals to Z0. If Zr equals to infinity, we have seen that Zin acts like an open circuited line. The transmission line acts like an open circuited line, and Zn is equal to Z0 cot j beta L. If Zr equals to 0, the transmission line acts like an open circuit line, and Zin equals to Z0 tan j beta L. So what is Z0? Is equal to root of ZSC into ZOC. VSWR. It is voltage standing wave ratio. It is a scalar quantity. It is a ratio of maximum voltage by minimum voltage at any point on the transmission line. So VSWR is equal to E1 plus E2 by E1 minus E2, or 1 plus E2 by E1 by 1 minus E2 by E1. So this is equal to mod of K, and this is also K, right? So 1 plus mod K by 1 minus mod K. So we have seen K varies from +1 to -1. So let's see how S varies. So when Zr equals to Z0, K is 0 and S is 1. Okay. And when Zr equals to 0, K is -1, mod of K is 1, S is infinity. And when Zr equals to infinity, K is equal to 1 and mod of K is equal to 1 and S is infinity. So we have seen that for a short circuit line and for open circuit line, VSWR is infinity. So in a lambda by 2 transmission line terminated by Z0, Zn is equal to Zr. So we have seen Zn is equal to Z0 into Zr plus JZ0 tan beta L by Z0 plus JZR tan beta L. Okay. So beta is 2 pi by lambda into lambda by 2, because this is the lambda by 2 transmission line. So 2 pi by lambda into lambda by 2. Okay, so we calculate that, we get Zn equals to Z0 into Zr by Z0. So that is Zn is equal to Zr. Transmission line as an impedance matching network. In TV, at antenna we have 300 ohms and at TV we have 75 ohms. So for maximum power transfer, we must use a transmission line. So this should act like an impedance matching network. So let's see how it is acting like a. So what should be the length of transmission line? That is what we have to see. So Zn is equal to Z0 into Zr plus JZ0 tan 2 pi by lambda into, you should use a lambda by 4 line. So if you use a lambda by 4 line, substitute lambda by 4 over here, we get Z. Now take tan pi by 2 over here. So lambda cancels. So 2 times 2 is this 4, right? So you get tan pi by 2. So take this to the denominator, okay, of Zr, and take this to the denominator of Z0. So take a common of tan 2 by lambda, okay. So you get Zr by tan pi by 2 plus JZ0 by Z0 by tan pi by 2 plus JZR. So what happens? Zn will become Z0 into Z0 by Zr. So Zn is equal to Z0 square by Zr. Input impedance of a lambda by 4 line terminated by Zr is Z0 square by Zr. In a TV, Z0 is equal to root of 300 into 75, which is equal to 150 ohms. Lambda by 8 line terminated by Zr. Now if input impedance is Zn equals to Z0, okay. So let's see how Zn is equal to Z0. Zn is equal to Z0 into Zr plus JZ0 tan beta L by Z0 plus JZR tan beta L. Now substitute L is equal to lambda by 8. Okay. So you have substituted lambda by 8. So this becomes how much? Tan pi by 4. So tan pi by 4 is 1. So you get Z0 into ZR plus JZ0 by Z0 plus JZR. So this cancels out. So you get Zn equals to Z0. Transmission line as a resonant line. Lambda by 4 shorted line acts as a parallel resonant circuit. Let's see how it acts like a parallel resonant circuit. Now Zn is equal to Zsc is equal to Z0 J tan beta L. Okay, beta is 2 pi by lambda into, now L is lambda by 4. Okay, now substitute that, you get tan pi by 2, which is infinity. So Zn is infinity. In Zn, if Zn is infinity, Is is 0. So it is a parallel resonant circuit. Now let's see some more concepts. Lambda by 4 open circuited line acts as a series resonant circuit. Let's see how lambda by 4 open circuited line behaves like a series resonant circuit. You know that Zn is equal to ZOC is equal to Z0 J cot beta L. Now substitute L is equal to lambda by 4. So you get cot pi by 2, which is 0. So if Zn is equal to 0, Is is infinity. So it is a series resonant circuit. Now similarly, a lambda by 2 short circuited line acts as a series resonant circuit. You can substitute that in Zsc is equal to Z0 J tan beta L. You get the values, okay? And check a lambda by 2 open circuited line acts as a parallel resonant circuit. This you can check by substituting lambda by 2 in Z0 J cot beta L. Okay. So multiples of lambda by 4 lines when it is open or short circuit acts as resonant lines. So transmission lines of length between 0 to lambda by 4, which is short circuited, acts as an inductor. Let's see how it acts like an inductor. Now Zsc is equal to Z0 J tan beta L. Okay. Example, take L is equal to lambda by 8. So you get Zsc is equal to Z0 into J. So if it is lambda by 8, you get pi by 4. Okay. Which is, so you get J Z0. So it acts like a inductor. Now transmission lines of length between lambda by 4 and lambda by 2, which is short circuited, acts as a capacitor. Let's see how it acts like a capacitor. Take a value 3 lambda by 4. Substitute that in Z0 J tan beta L. So if you substitute that, you get Zsc is equal to minus J Z0. So it acts like a capacitor. Standing wave pattern. E is equal to E1 e to the power of j beta x plus E2 e to the power of minus j beta x. I1 is equal to I1 by Z0 e to the power of j beta x minus E2 by Z0 e to the power of minus j beta x. So standing waves are formed when voltages and currents are varying across a transmission line. Voltage standing wave pattern. So this is a voltage standing wave pattern. So when E is maximum, I is minimum, and when E is minimum, I is maximum. So this is lambda by 4 and this is lambda by 4. This is along a transmission line. Okay. So we see that VSWR and ISWR are equal, and Smith chart is used for solving propagation problems. Distance between two successive maximum points is lambda by 2, and distance between two maximum and minimum points is lambda by 4. So when E is maximum, I is minimum, and when E is minimum, we are saying I is maximum. At R max, that is equal to Z0 into S, R min is equal to Z0 by S. So when ZR is greater than Z0, maximum voltage occurs at the load, and when ZR is less than Z0, minimum voltage occurs at the load. Okay. When voltage gets added, current gets decreasing. So Emax, if the voltage is maximum, I is minimum. So Rmax is equal to Emax by Imin. So Emax substitute, multiply and divide, multiply the numerator and divide the denominator by the same value, okay? So E min by E min. So Emax into E min by E min into I min. So Emax by E min is yes. E min by I min is Z naught. So R max is S into Z naught. What is R min? It is E min by I max. So multiply and divide it by E max. E min by E max into E max by I max. R min is equal to Z naught by S. So when voltages and currents on a transmission line are varying, standing waves are caused. Power on each point of transmission line is same. Let's see how it is. P max is equal to E max square by R max square. So E max square by R max is Z naught into S. So E max by Z naught into E max by E min. Okay. So which is equal to E max into E min by Z naught. Now power P minimum. E min square by R min. E min square by R min is Z naught by S. And what is S? E max by E min. So we get E max into E min by Z naught. So we see power on each point of transmission line is same. Stub matching. Stub is a transmission line. It may be open circuited or short circuited. So short circuited stub is preferable to open circuited stub, as open circuited stub radiates signals. And stubs are used when ZR is not equal to Z naught. That is, it is basically used for impedance matching. Single stub is used for open wire line. It cannot be used in submarine cables. Double stub is used in wide frequency range. Now let's see the Z naught of a coaxial line. So this is a coaxial line, right? So this has the outer diameter is capital D, the inner diameter is small d. Z naught is equal to 133 by root k into log d by d.